Today, I'm here to explain about how to evaluate this value using local linear approximation. Of course, if you can use the calculator, you can easily find the value. But if you don't have any calculator, this value is really hard to calculate. So this time, let me just find the approximation. It's not exact number, but approximation. Let me find it. The formula is like this. Let me write it, but it looks a little bit complicated. So yeah, I will explain it later. So it's going to be like this. So let me explain about the meaning of this formula while I'm explaining about how to find the value of this one. So first of all, probably you can easily find the value of square root of 16, which is 4. Let me sketch the graph y equals square root of x, because this one is the form of square root of something. And for example, when x value is 16, the value is 4. But again, what you have to find is the value of square root of 16.08, which is probably somewhere here. The value up here. It looks complicated. So what I would do is, let me just zoom it up here. Yes. Then x value is 16.08. You have the value here, and also you have to find the value here. It looks a little bit complicated, but what I would do, what local linear approximation do is, first you find the slope here. Then using this slope, you know the value here, which is 0.08. So if you know the slope here, you can easily find this value from here to here, this value. So it's a little bit different. So you just define this value as the value of square root of 16.808. You know what I mean? So for example, if this slope is 1, if this slope is 0.5, this value is going to be half of it, 0.04. So the y value of this one is 4, so you can just easily add 4 plus 0.04, then you can easily find the value of 4.04. This is the local linear approximation. So let me try it again. 16.08. So first, this is the square root of x form. So when x equals 16, y value is 4. But again, you want to find the value of 16.08. So y, let me put this one as y equals 4 plus the slope. Let me find the slope here. Y prime of 16. And let me put y equals square root of x. Then y prime is 1 over 2 square root of x. So which is 4 plus 1 over 2 square root of 16 times, you find the x value here, which is 0.08 times 0.08. 4 plus 1 over 2 times 4 times 0.08, which is 1. So the answer is 4.01. So again, this is approximation, so it's not exact number, but this can be applicable when this value is really small. I mean, when x value and a value is pretty small. Let me work on one more question. So for example, if you have the function third root of 7.4, let me find the value of this one. So first, probably you can easily find the value of third root of 8. So let me sketch the graph like this. Let me put y equals third root of x, and probably can find when x equals 8, y value is 2. So again, what would you do is to find the value when x equals 7.8. So let me find the y prime. Y prime is 1 over 3 times x to the power of negative 2 over 3. So the value of y is 2 plus 1 over 3, but this time it's negative because it's a little bit smaller than 8. So negative 1 over 3 times x value is 8, 2 to the power of negative 2, 8 to the power of negative 2 over 3 times x value here, which is 0.6, to negative 8 is 2 cubed. 2 cubed times negative 2 over 3, which is negative 1 over 4. I mean 1 over 4 times 0.6. Let me cancel out. So it's going to be negative 0.05, which is 1.95. Yeah, that's all. So again, what you have to do is first you have to find the value similar to this one. For example, in this case it's 8, and you try to find the y prime, and yeah, and you find the slope, then you try to find this value using local linear approximation.